Welcome back to Math with Amla. Let's move to the part 9 of grade 9 chapter 1. Here we deals with the continuation of exercise 1.3. Let's move to question number 5. What can the maximum number of digits be in the repeating block of digits in the decimal expansion of 1 by 17? Perform the division to check your answer. Here we have 1 divided by 17. Actually, we have to do the long division right now. So 1 divided by 17, we can't take any 17s inside 1. But by giving a decimal and giving some zeros with the 1, we can take 17s from that bigger number. So you can take 5 17s from 100. So the answer is 85. Remainder 15. You can give one more 0. Then 8 17s are 136. Remainder is 14. Then again giving one more 0 and you will get 8 17s are 136. Then the remainder 40. Let's give 2 17s inside 40, that is 34. Then again 60. Then there are 3 17s of 51. Then 9 remainder. Then you can give the 0. Then again 5 17s inside 90. Then 85, which is again 50 Then there are 2 17s inside 50, that is 34. Then you will get 160. Then again you can continue like this and you will get some 9, 4, 1, 1, 7, and at last 110, 102, 80, 68, 120, 119, then again 100. So here we reaches at the starting point, which means at this point this quotient will be repeating. The decimal expansion will be repeating with it some kind of numbers. So if we calculate the total number of digits which are repeating, it is actually 16 digits. Okay, so the question is how many digits? So you can say it like the number of digits in the repeating block of this division is 16. Okay, next question. Look at several examples of rational numbers in the form p by q, where q not equal to 0, where p and q are integers with no common factors other than 1 and having terminating decimal representations or expansions. Can you guess what property q must satisfy? Here in this question, you're having the definition of the rational numbers which is of the form p by q, where q not equal to 0. Also, there is one more condition, that we should take a terminating decimal expansion. For that, we have to take the q as always 2, 4, 5, 8, 10 like that, because only with this denominators or with q, we are having a terminating sequence. 1 by 2 is equal to 0.5, where q is equal to 2 raised to 1. 7 by 8 equal to 0.875, where q is equal to 2 cube, which is the 8. 4 by 5 is equal to 0.8, where q is equal to 5 raised to 1. So we can generally say it like, if we have the q with 2's powers or 5's powers, then that will be a terminating decimal expansion of the rational. Next, the 7th question is to write 3 numbers whose decimal expansions are non-terminating, non-recurring. It should not be recurring, at the same time it should not be terminating. Let's see. Let's take the irrational number root 3, whose decimal expansions is 1.732050807568. Actually, this value is not terminating or non-recurring. Nothing is getting repeated in between. Root 26, root 101. These numbers are having different numbers when we divide with the continuous long division method. The next example we can give is pi value, which is having 1.2 trillion values or decimal places right now. 8th question is to find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. 5 by 7, its value is 0.714285 bar. It is a repeating value or it is a recurring value, recurring expansion. 9 by 11 is 0.81 bar. So we have to find some numbers in between. So actually we are having different numbers in between: 0.7, 0.8, 0.71, 0.81. You can cite different numbers like this. 0.7307, 3007, 300007, 30000. You can make a pattern in it like this. Okay. Next is classify the following numbers as rational or irrational. The first question, root 23 is equal to 4.795831523331, which is an irrational number because it is a non-recurring, non-repeating number. Next is root of 225, which is equal to 15. We know 15 square is 225. So it's a rational. It's a terminating expansion. Hence it is a rational number. Then third question, 0.3796. Can we represent this as a rational number? Yes, because it's a terminating sequence. Next one is 7.478478. Actually, there is no bar given, and also it is continuing. Nothing is repeating. So it is an irrational number. Then the fifth one is 1.010100100001, and it goes. It is non-terminating and non-recurring. Hence it is an irrational number. Okay. Thank you for watching the video. Clear your doubts through comments. Please stay tuned for the next part, which contains rational operations.